In this short video, we're going to go over the idea of optimization. So to optimize something in math or outside of math means to make the most efficient use or the best use of something. To do something the best you can is to optimize it. You can think this comes up a lot in different mathematical applications. For example, in business, if you want to do something with the least cost or the most profit, you would optimize. In engineering, if you want to use the least materials to build something, or you want to make the largest machine that fits in a given size, or you want to find the most efficient process or the best route. Those are all examples of kind of real life optimization. In math, optimization means we want to make something as big as possible, so we'd find a maximum, or we want to make something as small as possible, so we find a minimum. And so either of those in our course means finding the vertex of a parabola, right? So every parabola has got either that maximum or that minimum. So whenever you see the word optimize or maximum or minimize, we want to always be trying to find the vertex of a parabola. So here's an example. A punter is kicking the ball, and the height of the ball in feet after t seconds follows this route. We've seen similar equations before. This is in standard form. We know it opens down, which makes sense. If you kick a ball, it's going to start up and then eventually it's going to come back down. That's gravity. And the c value in standard form also tells us our kind of initial value, or our starting point from where the punter kicks the ball. So we have height and time. I always like, anytime we do a word problem, I think it's helpful to draw a little sketch. We want to figure out what's the maximum height of the ball. In other words, what's the highest height that it reaches, the largest h value. So we need to find this point here, the vertex. Well, to find the vertex, we should have the parabola in standard form. So what we're going to want to do is complete the square. So anytime we're looking to find a vertex or to find an optimum, it probably makes sense to complete the square. So what I'm going to do is I'm going to factor out the negative 4.9 from the first two terms. So I'm left with t squared, and then positive 24.5 divided by negative 4.9. We could use our calculator. So 24.5 divided by negative 4.9. I've got t squared minus 5t. And I'm always going to leave my third term outside the brackets because we're going to want it by itself at the end anyway. And then we're going to complete the square. We're going to follow that perfect square trinomial process inside the brackets. So I'm going to take half of the middle number and then square it. So half of negative 5 is negative 2.5. When I square it, I'm going to get a positive 6.25. So I'm going to add that number and then immediately take it away. And that's all within the brackets. I really only want these first three terms in the bracket. Those are the three terms I want to factor, so I've got to remove the negative 6.25. I've got to kick it out, so I need to distribute the negative 4.9. So in other words, I need to multiply negative 4.9 by 6.25. And what that's going to do is remove it from the bracket. So now I don't have the negative 6.25 in the bracket. I'm going to do negative 6.25 times negative 4.9. So then I'm going to add another 30.625. Okay, my last step is to factor the inside. These three terms. It's always going to be half of the middle. So I'm going to have t minus 2.5 squared, and then collect the last two. So that's plus 32.625. So there's my parabola in vertex form. Now I've done all the hard work. Now we just need to interpret. So my vertex is 2.5, 32.625. And instead of x, y, what we have now is we have time and we have height. So this is my vertex. So the maximum height I reach must be 32 meters. So the maximum height of the ball is 32.625 meters. So often the challenge here can be kind of interpreting what answer we get. So we found the vertex, but it's just a number, it's just a value, our optimal value, which is 32 meters. That's how high the punt gets. I think that'll be a pretty good punt in the NHL. It might be feet, actually, not meters, now that I think about it. What time does this occur? So the vertex has two pieces of information. It has the optimal value, and it also has, when does it occur? At what point does it occur? So at this point, that's a quick one. It just occurs after 2.5 seconds. So if we're trying to optimize something in this course, that means we're trying to find the maximum or the minimum. That means we should be looking for the vertex by completing the square and then interpreting the coordinates of the vertex to answer any types of questions. That's it. Pretty short video today. And let me know if you have any questions. Okay, thanks for watching.